The question that I have is, could you tell us where we might encounter a 3D rigid body? So let's start with the simple question of what is a 3D rigid body? The answer is simple. We live in a 3D world, right? And therefore most structures are three-dimensional. But in some cases, some design questions can be answered using two-dimensional approximations. Here is an example of that. We have a concrete dam, right? And it is a three-dimensional object, right? Now, if I do want to analyze the whole thing, including the abutments over here, right, then the analysis is three-dimensional because we have a three-dimensional geometry, three-dimensional loading, and therefore the problem is three-dimensional. On the other hand, many of the design questions can be answered simply by considering a two-dimensional section, like this one right there. All right, so I take a section right there, and the cross section is going to look like this, and now I can analyze this as a two-dimensional body. So this is usually how we come up with two-dimensional rigid bodies from real structures which are actually three-dimensional. But obviously, analysis of two-dimensional sections like this can only answer some question, not all the question, because, for example, this won't be able to address the forces acting on the abutments here, right? Even though we always try to look for two-dimensional approximations, in some cases it may not be possible. Here's an example where a two-dimensional approximation is not possible. Say I want to analyze just the porch here, right? All right, so you can see this is a rectangular object, but the support system is not symmetric. You have this cable attached to this point on the building and this point on the porch, right? So this makes this a three-dimensional body. It's not possible to come up with a two-dimensional approximation to analyze this, and therefore we're going to have to analyze this as a three-dimensional body. On the other hand, if the arrangement had been something like this, where several cables are used instead of one cable in a symmetric manner, then we could come up with a two-dimensional approximation to analyze this. So here's the 2D approximation that I would use in the analysis. I'll take a little section on this plate, right, and then approximate that as a two-dimensional body. Well, you might say, well, if I take the section right at the point where the cable is, that section is different from if I take a section in between the cables, right? That is true. But if the cables are closely spaced, then this type of approximation usually works reasonably well. So you can see truly two-dimensional structures don't exist because we live in a three-dimensional world, but two-dimensional approximations can be used in many cases to analyze structures. So we spent a lot of time talking about 2D rigid bodies and the analysis of them. So let's look at the similarities and differences between 2D and 3D analyses. In a nutshell, the fundamentals are the same, so they differ only in details. For example, in both types, 2D and 3D, we need to define the body to be analyzed. We need to develop a free body diagram for the body to be analyzed. And then we use equilibrium equations to solve for the unknowns. The unknowns are the support reactions and the internal forces. So what are the differences? Well, support types are going to be different. The number and directions of support reactions and internal forces are going to be different. The number of equilibrium equations that we can write down is going to be different. It's 3 maximum in 2D, 6 maximum in 3D.